Solving another question which was asked in the fluid mechanics and machine gate 2020, in which this question is based on basically the continuity question. So before solving on to this question, let us just have a quick look on the continuity question and the Bernoulli question which we are going to apply for this question. So we all know that the continuity equation basically is derives for whatever the inlet area density and the velocity would always be equal to the area density and the velocity at the outlet, right? That is the rate at which the mass enters would be always equal to the rate at which the mass leaves, right? And one thing which you must remember, like the continuity equation applies to all kinds of the fluids, like the compressible and the incompressible fluid, or either it is the Newtonian or the non-Newtonian fluids, right? So usually, I mean, this type of you might have seen in your household pipes or tubes or these ducts in which the fluid enters from the one end and leaves from the another end, right? So in order to solve out the kind of the variations which is happening, we apply the Bernoulli equation, which states that the total mechanical energy of this moving fluid, and which comprises of different types of the energy, like the potential energy if it is moving to the elevation, gravitational energy, and the energy associated with the fluid pressure, as well as the moving energy of the fluid, which is the kinetic energy, that all remains the constant, right? So this is the assumptions which we do take while solving the questions related to this fluid flow, right? So now coming to the question which was asked in the GATE 2020, in which according to diagram you can see the air discharges here, the fluid which is which the examiner is talking of, it is the air. So the air discharges so the air discharges steadily through a horizontal nozzle and impinges on a stationary vertical plate as shown in the figure, right? So inlet pressure has been given, the inlet and the outlet areas of the nozzles we have been given. Take the air density constant as 1.2 kg per meter cube, and the inlet gauge pressure of the air is 0.36 kilopascal, and we have to find the gauge pressure at this point, that is the point O, right, in the kilopascal, that we have to find out. So we'll first of all, what we'll do is we'll apply the this continuity equation, right? So mass flow rate would be rho 1 a1 v1 is equal to rho 2 a2 and v2, right? So it would be zero point 0.1, right? v1 is equal to 0.02 into v2, and if it this 0 and this 0 would be cancelled out, so the velocity would be, outlet velocity would be the 5 times of the initial velocity, right? So now next, after applying the Bernoulli equation in between this point 1 and this point 2, so what the Bernoulli equation would be, it would be P1 plus V1 square, P1 divided by rho g, plus V1 square by 2g, plus Z1 is equal to P2 divided by rho g, plus V2 square by 2g, plus Z2, right? So this and this would be cancelled out. No, sorry, this would not be cancelled out. Just a second. Now since the plate is stationary, this would be the equal to 0, right? And if we try to solve this out, it would be 0.36 into 10 to the power 3, because it is in the kilopascal. First of all, we'll try to solve it in the pascal. V1 square, which would be equal to the V2 square. So V2 is equal to 5 times of V1, which is equal to 25 V1 square, right? So this 2g and 2g would also get cancelled if we try to solve this out. Just a second. Yeah. Right. So rho is 1.21 multiplied by 9.81 divided by 2g divided by 2g, right? So if we solve this equation, we'll get v1 is equal to 4.98 meter per second and v2 is equal to 24.9 meter per second, right? So now what this is our point 3. So if we'll apply the Bernoulli's equation between point 2 and the point 3, what similarly we'll get P3 equal to rho g into V2 square divided by 2g, which is equal to 1.21 multiplied by V2, which is 24.89 square divided by 2, right? And if we solve this out, it would be 375 Pascal, right? And if we convert it in terms of the kilopascal, our P3 would be equal to 0.375 kilopascal, right? So the correct answer would be 0.35 kilopascal, which is the gauge pressure at the point O, right? So this is how we do apply the Bernoulli's equation to solve the problems like this, right? Thank you.